Hello everyone, welcome to new class. Today's class is about problems on AC circuit. That is the second part of the AC problems. If you didn't watch the first part, please watch the part 1 of problems on AC circuit. Let us go through the problems. Find the average and RMS values of the current. I of t is equal to 10 plus 10 sine omega t. So this is the problem. We have to find the average and RMS values of the current. And the average value is the constant term, that is 10 ampere, because the average of sine omega t is 0. So average value is the constant term. If there is no constant term, then average value equal to 0. So here the average value is 10 ampere. And to find the RMS value, there are two methods. Either we have to find the square of the instantaneous value first and then find the square root. Here I is 10 plus 10 sine omega t. So we have to find the square of this value first. For that we have to know the sine terms, that is 1 plus sine square omega t. That identities we have to know. So another method is IRMS is equal to square root of 10 square plus 10 by root to the whole square. That is, this is in the form of Im sine omega t. This is Im sine omega t. So from this IRMS is equal to Im by root 2, that is 10 by root 2. And to find the RMS value, square root of 10 square plus 10 by root to the whole square. Then we will get the RMS value of the current, that is 12.247 ampere. Let us do another problem. Find the average and RMS values of the current I of t equal to 10 sine omega t plus 20 sine omega t minus pi by 2 plus 15 sine omega t plus pi by 4. So here there is no constant terms. So the average value of the current is equal to 0. To find the RMS value, square root of 10 by root to the whole square plus 20 by root to the whole square plus 15 by root to the whole square. That is equal to 19.04 ampere. Let us do another problem. In an AC circuit, the voltmeter and ammeter is connected and shows 220 volt and 12 ampere respectively. Calculate the maximum value and average value of voltage and current. Here voltmeter and ammeter reading is given. The voltmeter reading and ammeter reading is equal to RMS value of the voltage. This is RMS value of voltage. And here ammeter gives RMS value of current. So VRMS equal to 220 volt and IRMS equal to 12 ampere. To find the maximum value of voltage, Vm equal to root 2 VRMS, that is root 2 into 220 equal to 311.12 volt. And average value is 2 Vm by pi. equal to or 0.637 Vm, and we get 198.18 volt. To find the maximum value of current, Im is equal to root 2 Irms, and we get 16.97 ampere, and average value is equal to 0.637 Im, that is equal to 10.8 ampere. Next problem. When an AC supply with a supply voltage of 250 volt is applied across the circuit, the current in the circuit is found to be 25 ampere. If the current is at 0.8 power factor lagging, find the impedance of the circuit in J form and its magnitude. So take the voltage as the reference vector. Then the current lags at an angle of cos inverse 0.8 because we know only the power factor. So power factor is cos phi. Then to find the angle cos inverse 0.8. So this is the lagging angle of current, and this current has two components. The active component is I cos phi, reactive component is I sin phi. So in vector form, the voltage is 250 plus J0, and we get phi as 36.86 degree. From this find sin phi, that is sine of 36.8 is equal to 0.6. Now to find the current, that is current has two components, I cos phi minus J sin phi, that is here the current is lagging, so the sign of the imaginary part is negative, and we get 25 into 0.8 minus J 0.6, that is 20 minus J 15 ampere. Now we have to find the impedance. Impedance is equal to V by I, that is 250 plus J0 divided by 20 minus J15. Either you can take the conjugate of the denominator and solve this problem, or you can convert this rectangular form into polar form and divide, and after that again you can convert to rectangular form, or from that also we get the magnitude of impedance. Now I will discuss about the conjugate method, that is take the conjugate of the denominator and multiply with the numerator and denominator, that is 250 plus J0 into 20 plus J15 divided by 20 minus J15 into 20 plus J15. Then multiply these one, that is here the imaginary part is 0, so 250 into 20 plus 250 into J15, and here this is in the form of a minus b into a plus b, that is equal to a square minus b square, that is 20 square minus j square 15 square, and j square is equal to minus 1 because j is root minus 1 and j square is minus 1, and here we get 400 plus 225. And after solving this, that is divide these real part and imaginary part with the denominator term, and we get 8 plus j6 ohm, and to find the magnitude of impedance, root of 8 square plus 6 square equal to 10 ohm. Here the question is to find the impedance in the J form. So I did this problem in this method. Then to find the magnitude, square root of real part square plus imaginary part square. Let us do another problem. An alternating voltage 250 plus J0 volt is applied to a circuit having a resistance of 8 ohm and inductive reactance of 6 ohm at 50 cycles per second. Find current in J form and its magnitude, power factor and power factor angle of current. Here the voltage given is 250 plus J0, and here there is resistance and inductive reactance. So impedance is equal to R plus Jx form, that is 8 plus J6 ohm. To find the current in J form, current is equal to V by Z, that is 250 plus J0 divided by 8 plus J6. Then multiply the numerator and denominator with the conjugate of denominator, that is 250 into 8 minus J6 divided by 8 plus J6 into 8 minus J6. That is 250 into 8 minus 250 into J6 divided by, this is in the form of a square minus b square, that is 8 square minus j square 6 square, and we get 100. So the value of current in J form is 20 minus J 15 ampere. Now to find the magnitude of current, square root of real part square plus imaginary part square, that is equal to 25 ampere. Now to find the power factor of current, cos phi, that is cos phi is equal to the real part of current, that is 20 divided by magnitude of current, 20 divided by 25, that is 0.8 lagging because inductive reactance. Or you can find cos phi equal to R divided by Z, because here we know the value of resistance and impedance, the magnitude of impedance you have to find, that is square root of 8 square plus 6 square. Then you can find the value of power factor like R by Z. And the power factor angle is cos inverse of 0.8, that is phi is equal to cos inverse of 0.8 equal to 36.86 degree. Thank you for watching the class. If you like the classes, please like, share and also subscribe my channel.